I'm going to talk about electrical, and I'm going to publish it on the internet, YouTube. Which probably isn't a good idea. Okay, so in this video, I am going to talk about how I'm going to redo the power coming into the shop. I won't be covering yet the power inside the shop itself, just the power coming to the shop. Now, if you remember, in the first video, I mentioned that ultimately this shop is temporary. We have some long-term plans that actually include tearing the shop down and building a new one. But for the time being, I want to make this shop more usable. And part of that is redoing the power. Why am I redoing the power? Well, there's a couple of, maybe a few different reasons. I'm going to have to redo all the outlets anyway for a couple of reasons. One, there's hardly any outlets in here. There's 1, 2, 3, 4 outlets. There were 8 outlets there, but where the window was, or where the window is. I want to redo how the power is coming in. Currently the power is coming in from the main breaker panel in the house, and it's still going to come in from the main breaker panel in the house, but I'm going to actually put in a sub panel. The other thing is that while there is 220 coming into the shop, the ground is being used as the neutral, which is technically not okay. So I decided that I'm going to go ahead and just rip all of this out, pull the old cable, this Romex, from the panel in the house and just redo it all. So what I'm doing is I'm going to run number 4 THHN or THWN wire, and I'm going to run a 70 amp circuit. Now 70 amps only because the wire, currently it goes up into that attic space, and then it goes out where that hole is, and then down into the conduit, down underneath our driveway, back up to the house, and then through the attic. So it's the through the attic part, it's that transition, because you can't, well, let's be honest, you can, but you're not supposed to run THHN or THWN outside of conduit. So because I don't want to have to run conduit all the way from, in the attic to the main breaker panel, I'm going to be switching to NMB wire, same gauge, number 4. So that limits my amperage to 70 amps, but I will be running 4 wires, well, 3, number 4, and then a proper ground. So I'll have 220, 70 amps. I've got a new breaker panel, which physically the size is probably overkill, except for the fact that my plan is that this wall will be a circuit, this wall will be a circuit, that wall will be a circuit, there may be some outlets there, and then the lights will be on a circuit. And then I probably won't right away as I need them, because it's all going to be conduit and surface mounted. If I need 220, I can add a 220 circuit. So before I can put the new power in and mount the panel and everything, I need to insulate and sheet this wall. Now I wasn't planning on doing this right away. I was actually planning on insulating and sheeting and then doing all the power stuff, so I could do all the actual outlets and everything at the same time. But since we're doing some electrical on our house anyway, unrelated electrical stuff on our house anyway, and I'm gonna have the power off tomorrow, I figure I'm just gonna do it all at once. So I'm gonna get it run, then I'm gonna temporarily scab in the existing wire into the new panel. So we'll see how it goes. right, so the new panel is in place. I've got lights back in the shop. It's just temporarily scabbed in using the old feeder cable. It's going up there to the individual wires that go to the lights. I'm not going to show you that because it's a little sketchy, but it's just temporary. So I just wanted to go over a couple things just to make sure that they were clear. In the first part of the video, after I pulled a wire through the conduit that goes between the shop and the house, I showed a shot of me terminating some connections inside a junction box. And what that was the transition between the THHN individual wires that are coming from the shop to the NMB wire that runs through the attic down to the main breaker panel. And the reason for that, again, is because I don't want to have to run conduit to the main breaker panel. And since you can't run, well, since you're not supposed to run THHN, THWN wire outside of conduit, I had to switch to NMB, Romex, if you want to call it that. And that shot, which I'll stick in here somewhere, is that transition point between the two. The NMB wire comes through the side of the house into that junction box. There's a little clamp to hold it in place. And then the transition between the two sets of wires takes place in that junction box. Now, one thing I encountered when I was planning this project was how do you splice together, because I have that transition between the individual wires and the NMB wire, but how am I supposed to splice those wires together? Number 4 wire is pretty big. They don't make wire nuts for this. I knew about split bolts, but that's a whole thing, and it just seemed really inconvenient. You know, it involves putting a split bolt on and wrapping tape around it in a certain way. So I started doing a little bit of digging, and I came across these connectors, and that's what you see me using in that shot. And these are Polaris connectors made by NSI Industries. Now, they're expensive, but they are convenient. These particular ones can be as much as $12 a piece. I did see some places trying to sell them for $20. These particular ones are for 4 to 14 gauge wire, which works out because I need to put 4 gauge wire in for the power, and then the ground is an 8 gauge wire. Okay, so this is the connector, and as you can see, it's just covered in plastic. That's an aluminum block in there, and there's 2 open holes, and then there's 2 plugged holes. So what you would do is you'd pop the plugs off. There's a flathead screwdriver in each of those holes, which you can't see, but you would back those off, and then you would just slip the wires in there and then tighten the screws down, and then pop your plugs back in, and you've spliced the 2 wires together. So a lot easier than using a split bolt and safer than just trying to tape them together. Now, the other thing I want to point out is that I do have a separate neutral and a separate ground coming to this panel, and the neutral and the ground at this panel, because it is a sub panel, are not bonded together or tied together. They're not electrically connected together. The only place that the neutral and the ground are bonded together is at the main panel. Because this is a sub panel, according to the NEC, the ground and the neutral are not supposed to be bonded together. You see a lot of confusion about this online, a lot of people saying that it doesn't matter. You could argue whether or not it does, but according to the NEC, if you want to do a sub panel properly, the neutral and the ground are not supposed to be bonded together at the sub panel. They're separate. The last thing I want to talk about is actually pulling the wires that run from the shop to the house through the conduit that runs between the shop and the house. Now, this is the part that I was worried about the most, that I thought would be the most difficult and cause the most problems. Turns out it actually wasn't that bad. So how do you actually pull the wires through the conduit? First, it's important to know the size of the conduit that you're going to be using, or that you are stuck using. In my case, it's 1 1/4 inch. So for 3 number 4 wires and 1 number 8 wire, in my case, 1 1/4 inch conduit is plenty big, very little chance of it jamming up in there. You don't want to go stuffing too many wires, too big of wires in a piece of conduit. And there are NEC rules on how many wires of a given gauge you can put in a given size of conduit. There's charts and calculators and stuff that you can find online to give you an idea of how many wires you can stick in and what the jam probability is and all that kinds of that stuff. So how did I actually run the wires? Well, you saw in the video, and I'll insert that clip in here somewhere, that I used the old wire, the old feeder cable, to pull a pull tape through the conduit. And then after I pulled that pull tape through, you saw that I actually pulled a rag through the conduit just to make sure that it was cleaned out, that there wasn't anything in there that shouldn't be in there. And I'm actually glad I did, because as you saw in that clip, there was some line in there, and that could have caused problems in pulling my new wire. Beyond that, it was actually fairly simple. I just bundled the wires together, made sure that they weren't tangled. You don't want them weaving in and out of each other. And then I think I took about 1 foot of the pull tape and taped it with electrical tape all the way from the bottom to the top. Put a nice little rounded nose on the bottom so that it could round the two elbows in my conduit run, one on the house side and one on the shop side. And so it was just a matter of taping that fairly tight, 2 or 3 wraps of electrical tape, again, round nose. And then once the cable was wrapped on the pull string, it was just a matter of feeding it in on one side and pulling it on the other. And that's the other thing. For wires this size and this length, this is a job that takes 2 people. And as you saw in the clip, my lovely and patient wife was helping me. And basically what that consisted of was one of us being on one end, pushing the wires in and feeding them in, and the other person on the other end pulling the pull tape to pull the wires through. The wire does get jammed up if it stops moving through the conduit. The couple of times that I've done this and having run Ethernet cable and stuff like that, which is a little bit different than this, that I found that's best is not to try to force it through. You'll never get it through. If the wire is caught on a lip of like a transition point or something like that, you're never gonna jam it all the way through. The thing that's best to do is actually to pull it back a little bit and then push it through, and pull it back a little bit and push it through. Eventually, you'll get past whatever, assuming it's something that you can get past. If it's like a lip of a transition or something, you'll get past that point and be able to pull it the rest of the way through. And the last thing that's important when you're pulling wire like this is plenty of lubrication. And I'm not joking. This was a fairly short run, but still, you want to make everything as easy as possible, so use plenty of wire or cable lube. And basically what that consisted of was the person that was on the end that was feeding the cables into the conduit would squirt a little bit of lube every once in a while to make sure that it was getting on the wires. By the time the wires came out of the other end, they were all goopy and gross, but the lube helps so you don't have to put too much tension on the wires when you're pulling them through. Helps make sure that they don't get jammed up. It's lube. It helps lubricate things. It helps make things go through things easier. All right, so that's it for this video. The next step is to finish insulating and sheeting the rest of the walls, and then start running some electrical for the outlets and lights and things. So if you like this video, please give it a thumbs up. Be sure and subscribe if you're not already, and hit that bell icon because YouTube likes to mess around with subscriptions and notifications and things like that. Bell icon is currently the best way to be notified when I post a new video. Oh, and one last thing. If you are a patron, I'm going to be putting up on my Patreon page just a short video, very short, about why this switch box that I showed in the first part, this was the original, where the original feeder cable terminated and where all the outlets and light wires terminated, on why this is actually more dangerous than it may have seemed at first. So if you're a patron, you can head over to my Patreon page, you can see that video. If you're not a patron, you can become a patron, and then you can see the video. See you next time.
Thanks for watching, like and subscribe.